Hi, I'm Bruce, and welcome to my Baptronics Mountain Labs. And tonight I'm going to be demonstrating the last of my B&K Precision 1856 1.3 gigahertz counters. This particular counter is the fourth in the series, fourth and last. It's a very handsome counter. Nice case, very few scratches, a couple of very minor ones. I don't even think they would show on here, but Mars more than a scratch, I suppose. But basically, it looks like a new unit. They were taken very good care of. No scratches at all on the faceplate. Nice shiny plastic case. Got the feet on it. Nice handle. And as you can see in the, I have photos of the same thing, but the serial number on this is 222-00079. So what we're going to do is we're going to take it through its paces. We're going to check channel A and B for the limits of their range as stated. A is 5 Hz to 100 megahertz and B is 80 megahertz to 1.3 gigahertz. And then we'll demonstrate a number of the other functions and we'll go from there. So bear with me, I'll set up and we'll take care of that. Okay, so we're feeding the 10 megahertz signal in right now, and we can see that we're reading 10 megahertz down to the hertz. Let's put her in a 10-second average and see what we get. Going to take a few moments here, but hopefully we only get a minute fraction of a hertz off. Okay, we're seeing 0.2 hertz that we're off from the 10 megahertz. We'll go through one more time cycle. Just saw the gate flash. 0.2 hertz remains, so we're within 0.2 hertz of 10 megahertz on this unit. To do that, we're going to apply a 5 hertz signal from this HP3320B, and we've got that coming in right now. We are on the kilohertz position. We're reading 1 second, and we see that we have 5 hertz on display. If we go to a 10-second average, we should pick up an extra decade of another decimal place for the frequency, and we see 5.0, so that's good. So we've measured 100 megahertz and 5 hertz. That's the range of A. Let's go ahead and test out B. Okay, well, in order to check channel B, we have to range from 80 megahertz to 1 gigahertz. So what I'm using here is my HP8640B, and I've got a doubler on the output. And in this particular range right now, 64 megahertz range, my display is showing the actual reading coming out, which is of the unit, which is 40 megahertz. The doubler then would make it 80. That's 40 megahertz to 3 decimal places. So if I'm 80, there we go. I'm showing 80 megahertz to 4 decimal places, and if I was to raise it up another notch for range, let's see, 10-second average, you'll pick up one more decade and we'll see that we're 79 and change. There we go. So we're 79.99996 megahertz coming out of my my doubler. Anyway, let's go ahead and put ourselves back on a 1 second average. In fact, let's not do that. Let's go to the 0.01 second average. We're going up to the end of our range. So let's go ahead. We'll take off the RF output. Okay. And take off the lock. And now we raise our frequency We'll go all the way to the end. Alright, I'm showing 1099.55 megahertz, so 1.09955. And I'm showing 1.09955. And if I go to the 0.1 second average, I should pick up another decimal place. And I get 1099.549 and change. So let's go to the 1 second average. 1099.5494. So there we go. So the channel B is reading from 80 megahertz up to about 1.1 gigahertz, which is all I can get out of my HP. I would take you up to the 1.3, which is another 0.2 of a gigahertz, but I can't do it. However, we see that we are operating very well here. Well, let's go ahead and take a look at period and totalizer and a few of the other features. Okay, well, we're back to reading frequency on channel A in kilohertz, and we're at a 1 second time base average. We show 0.005 kilohertz. In other words, that's 5 hertz. But let's go ahead now, since we've already seen this particular test, let's move the function to period. What is the period of a 5 hertz signal? And what I'm getting is about 200,000 microseconds. Let's see if we can change our range just a little here to slow down the display jump. And I'm seeing, again, about 200,000, give or take 2 or 3 microseconds. So 200,000 microseconds would be a perfect 5 hertz signal. Let's go ahead and take it up to .500 hertz. And at 500 hertz, I'm seeing about a 2,000 microsecond display, which makes sense. So our period is working just fine here. And by measuring the period, you can get a lot more resolution at lower frequencies than you can by reading the frequency directly. I mean, obviously, we were reading only 5. That was our resolution, and was 1 hertz. And here we are getting a resolution down to approximately a microsecond, so pretty good. So if you need to measure very slow frequencies, this would be the way to do it. Let's go ahead and move ourselves to totalize. But first, let's move ourselves back down to 5 hertz, something we can see. Wrong button. Okay, we should see 5. There we go, 5 hertz. Let's now move our function to totalize. And you see that we're counting up. We're totalizing the incoming pulses. And at any point, we can decide to hold the count, or we can release it, let it count some more. We can reset and count over. And on the back, you'll find that there's a couple of inputs for start and stop on the totalize function that would allow you to start counting pulses based on an incoming signal. And finally, let's move to a check function. All right. If I'm in the 0.01 second range for A, and I'm in check, I'm reading 10,000 kilohertz. If I go to the 0.1 second, again I'm reading 10,000 but this time it's 0.00 kilohertz. And if I go to the 1 second average, I'm reading 10,000.000, so I picked up another decade. But what I'm actually doing is I'm looking at the internal clock. I'm counting the pulses from the clock, and in a 1 second time range I'm displaying them on my counter here. So I'm looking at all of my displays. I see that they're functioning. I'm counting. I'm seeing that my counter is producing a 10 megahertz output, and it's sort of a quick check just to see that everything is working as it should. And we also have a times 10 attenuator, so we can cut down a larger signal, divide it by 10. We have a low pass filter. We see our gate light flashing here. We've got kilohertz or megahertz lights. We've got an overflow indicator, indicates when we have exceeded parameters. So that's it. Very nice looking unit, handsome, very large displays, nice and bright, nice calibration, and it's functioning beautifully. So along with that, I'll give you a manual on CD for operation and maintenance. I've got the schematics to the unit. That'll come with it. And I want to wish you happy bidding, and thank you for listening.